Let's build a road. What sorts of engineering problems did Crozet have to face in the early 19th century? One category of problems had to do with location. One would build a direct line if possible, but it was always expected that you'd have to go deviate from the straight line for various reasons. A 15% increase was okay. A 25 or 30% increase meant you had to provide some sort of explanation. But remember that in the mountainous terrain of Virginia, the road around a mountain might actually be a shorter one than one that goes over the top. Sometimes insufficient deviation called for sharp criticism as well, because too steep meant impassable or too costly for horse-drawn wagons. Were there other roads in the area that provided some source of competition? It was often difficult to convince turnpike officials to actually use the line that the engineer may have recommended. Was there a need to pay farmers along the line for damages to their property, for the appropriation of their property? And indeed, sometimes mistakes of location ruined some turnpike projects. There's also the problem of what were called summer roads. Once a road got built, and if it was heavily traveled, ruts often developed. And in the summertime, people would ride up alongside the road. And so we ended up with basically two roads running side by side. Another part of the engineer's job was to estimate costs. And estimating costs was enormously difficult in road construction. The actual price of labor was often higher than expected. The cost of excavating rock was high, and one never knew just how much excavation might be necessary. All sorts of details added up, the incidentals added up. So costing was a part of the engineer's job, but a relatively imprecise one. How to establish a grades for roads? There were lots of different ways for measuring the grade of a road. Should it be measured in terms of the angle with the horizontal? Should it be measured as a proportion between the vertical ascent and the horizontal distance? Should it be measured in ascent in feet per mile? Or how about just percent increase as increase? The figure that was most precise, and the one that was used most often by Crozet and other engineers, was to talk about a number of feet of increase per X number of feet of travel. So how many feet of horizontal distance was necessary to achieve 1 foot of vertical ascent? For example, 1 foot per 57 feet of travel. They needed to calculate the angle of repose. The angle of repose was the angle at which a vehicle would remain at rest, assuming friction. 1/35 was judged to be normal, or an excellent angle for operating for transportation in both directions. This is roughly 1.5 degrees. 1/20 was also good. We're now at roughly 2%. Crozet permitted in his designs 3 degrees. However, in actual completed turnpikes, 5% and even more was often common. The deviation now is going to start illustrating the difference between Crozet's role and the roles of the contractors and the chartered companies. Another big issue was drainage. How do you keep a road dry? They had to design gutters, ditches, culverts. The problem was rounding the surface on hillsides as well as on level ground. A lot of the companies wanted to build rounded roads even when they're on the hillside, and Crozet had to try and convince them that you didn't want to round them because you'd end up building even deeper ruts along the hillside. Surfacing was a big issue. A lot of the roads were very muddy, and indeed less thought was given to surfaces than to a lot of other things. In Virginia and in other states, a competition developed between two alternative modes of surface construction, both of which were British. But the difference between the two does illustrate the differences between the British and the United States. The names associated with this competition were macadam and Telford. Macadam's method of developing surfaces basically involved providing one layer of relatively large stones that were somehow with just the right amount of moisture, and then another layer of smaller stones, and another layer of smaller stones, and another layer of smaller stones. In other words, layer after layer of stones, each with a certain amount of moisture in them, providing what was pretty effectively a water-bound surface. Now, the Telford method was somewhat different. Telford, his method involved taking rather large stones, sitting them on the side, putting them side by side by side by side by side, and then putting layers of small stones over top. Now, can you imagine and can you think through which method might be more appropriate in the United States and which method more appropriate in England? Because the Telford method was much more permanent, demanded much more care, and the production of which demonstrated strong and capable craftsmanship, the Telford method was the one that was more acceptable in the British context. Meanwhile, the macadam method could be done with unskilled workers and could be done more cheaply and provide more mass use. Hence, it became more appropriate in the American context. And so one often heard about a desirable road was a macadamized road in the United States. Engineers are also working on building bridges. But prior to the middle of the 19th century, these were basically wooden bridges on abutments and piers. Lattice plans were not very well developed, and there were an awful lot of bridge builders out there who are of relatively doubtful integrity. It's not until we get to the middle 19th century and later 19th century that the civil engineers are developing solid designs and in ways that provided quality bridges over long distances.